Hi everyone. Thank you for joining me in this new video. Today we are going to talk about the two main functions that we have inside Control4 to handle timing between execution of programming. Basically, these two tools are timers and delays that they main seems to be quite similar, but actually they are two different animals and we need to understand each one of them because it's very important in order to make good programming and to avoid unwanted situations or misbehaviors in some programming that we could do in our clients' projects. We are going to cover the concept between each method, and we are going to program a case of study with the two methods and to compare the different situations to see the behavior, the real behavior of each method. In this case, finally, I am going to detail the advantage and disadvantage and best uses scenarios for each of these methods in order to have a very good knowledge of these functions and to make very good programming. Let's get started. As you know, I always like to start with the concepts. Delay is basically a function to hold the execution of the next commands in the programming until the time expires. So basically, you tell to director to do nothing until the time expires. Um, This is similar, for example, as an analogy, as traffic lights. If you are in a traffic light, you can't do anything else more than wait until the green lights turn on to continue. On the other hand, we have the timers. Timers is a total different function inside Director that handles all the timers, not only what you are going to program, and the concept is different. You tell director, okay, I need to do something and in, for example, 20 minutes. I let you know that I need to start the timing now, and that's it. Director, what you're going to do is when he checks all the timers in the background, and when the timer expires, it's going to come back with the next part of the programming. That's why also in the programming they are programming very different delay and timers. This is similar to an alarm. Suppose that you are cooking and you need to wait 30 minutes. You set an alarm of 30 minutes and you go to do other things. And when the alarm rings, you come back and you continue with the process of the cooking. In the programming world, we call this type of delays as a blocking behavior, but because literally you block the execution of the project. The process is halted because you are using resources in halts, waiting to finish the timing. So you can't do anything else with that thread, in this case, on the director. The timers are what is called a not blocking behavior because you have a separate function that is only programming to check all the timers, and the process is not blocked. So this is basically the concept behind delays and timers. The best way to see this on the field or is with an example. We are going to make a programming of a case of study with the two methods. The case of study that we are going to program is basically, it's very simple, is this one. We have a gate that we are going to monitor with the gate sensor. And when the gate goes open for more than 30 minutes, we are going to send a push notification to the end customer to let him know that the gate had been opened for more than 30 minutes. Now, let's go to Composer Pro and make the programming of this example using delay first. Before continue, if you are enjoying this video, please give it a like and subscribe to my channel. This way you help me to reach more people that could be interested with this kind of content. Thank you. This is my demo project. Um, I have added a garage room, and inside that room, I have added a gate status sensor that basically shows the status of the gate. Ignore the rest of the room. This is for other purposes. Um, so basically, we are going to program against the status of this driver, this sensor driver. But before making the programming, we should prepare the push notification that we are going to need to trigger in the programming tab. So let's go first to agents, push notification. Let's add a new one, gate open. Let's set this security alarm and subject. For example, home. I always like to write down the name of the project. So if they have multi properties, it's easy to detect the from which a project is coming the notification. Home gate open for 30 min. Um, Actually, in a real case scenario, we have this attachment tool that is very interesting. If we have a camera, we could that is pointing to the garage or the gates. In this case, we can add that camera, so it's going to send a screenshot after the 30 minutes. It's like to have like this kind of double check that definitely the gate is open. But in this case, well, we don't have a camera, so cancel, and let's save application to use it later. So let's go back to system design. We can highlight the gate status, and we go to programming tab, and you can see that we are still here, and we have these two events for these drivers. When the gate status opens and when the gate status closes. So when we need to use this one when the gate status opens. And the idea using the delays is basically set a delay of 30 minutes, 30, select minutes, drag and drop, perfect. And what we need to do after the 30 minutes, let's go to push notifications and trigger the push notification. But let's add a feature here because here we are waiting 30 minutes and we don't know what is going to happen inside those 30 minutes. So uh, to avoid false notification, we can add a simple thing that we go to the gate status, we go to conditionals, and we check that the gate is open before sending the push notification. With this, avoid some false notifications. To analyze the way of working this programming, I would like to cover some situations and see what would be the behavior of this. Well, here I'm going to show you some graphics about possible scenarios of situations of this programming. So here we have basically this is an axis of time, and this is about status. We have the open and the gate close, the gate open, and watch this. Suppose this is a scenario. We have the status of the gate is closed, then goes to open, and then it's maintained open for a good amount of time. So here the event is triggered and the delay starts. So when the delay ends, it will ask, hey, do we have still the gate open? In this case, yes, we have. So we are going to send the push notification. So this situation is working as expected. Let's see situation number 2. Now we are going to have the gate opened for less than 30 minutes and then close again. So here the delay starts. We have the 30 minutes delay. And when the delay expires, it will ask, hey, do we have the gate open? No. So we are not going to send a push notification. Nothing happens. This works okay. Perfect. But let's see this last scenario. We have the gate closed, then we open it for less than 30 minutes, then we close it again for some period of time, and then we open it again. See what happens. Here we start the delay. The delay takes 30 minutes, and when he reach the point of the delay expires, he will say, hey, we have the gate opened. So let's send a push notification. But this is not the behavior we want, because here we have a gate open for a little bit of time, then close, and before it takes a full 30 minutes, we open it again for another things. So this is not the real behavior. The problem with delays is that we can't stop this. Once the delay starts, it can't be stopped. And another thing is that it can't be restarted, for example. So the limitation of delays, or one of the limitations, we are going to cover all of them in the summary, is this. This is not a good way to program this kind of functions, because we could have a lot of unwanted behaviors, or false triggerings, or false positives, as you want to call it. And the it's not a good programming quality, let's call that way. So let's go with timers and see what can offer us the timers to make this kind of programming more precise and accurate. First, let's erase this because if not, we have issues. And let's go with the timer. Um, First, as we did with the push notification, we need to create the timer in order to be able to program with it. So we go to the timer agent. If you don't have it, please remember that you can search for it here in Add Agents. So we go to timer and we call it max gate open time. For example, perfect. Here we create the timer. And well, in this case, we say 30 minutes, so 30:00. The timer agent, I am not going to cover the full capability of the timers, but basically here you can simulate different status, start, stop, restart, reset, pause, resume. Here you have a very good summary of every one of these functions and the behavior depending of the conditions. And you can also set this as repeating. I usually don't use it as a repeating function. If I need to make a repeat timer, I call it itself when it expires to start again. But it give you, from my point of view, better control. But well, it's not something important for us now. So we have already made the timer perfect. So let's go back to the system design, programming tab. And again, when the gate status opens, now we are not going to obviously use delay. We are going to set the timer. We only have this one, and we are going to start the max time, the max gate open timer. One thing that is very important is that this timer should be stopped when the gate status close. So before programming, I'm going to other view. I will make this first. So basically, when the gate status close, we're going to stop the timer. Okay. And now that we have already set the condition from the timer start here and stop here, we are going to go to timer list, and as we have only this one, we have only these events. But this is very interesting because the delays, you don't have any events to program against, and here the timers give you a lot of versatility because you can not also program against expires, but also has been started, has been stopped, has been resetted, etc. You have a lot of options. In this case, the only thing that we need to do is, if the timer was started and expires, now we go to the push notification and send the push. So you can ask me, hey Juan, we previously in the delay we use the conditional statement to check the status of the gate. In this case, it's not really necessary because as we make sure that when the gate is closed, this timer is going to be stopped. So it never going to be trigger these expired events if the gate was closed previously. So it doesn't have any sense to add the conditional. Is something that's in theory is going to be through always reaching this stage. So it's not necessary. So that's it. This is very simple. Now let's go to analyze the same situations that we did with the delays, but now using the timer. Right. Here we are going to cover the three same situations. First one, we open the gate and we leave it that way for a long time. So timer starts, timer takes 30 minutes, the timer expires, and we send them the push notification. This is working as expected. Perfect. Number two, gate open for less than 30 minutes, and then we are not going to open it again. Timer starts, 30, less than 30 minutes when the gate get closed, it's going to stop the timer, so nothing happens. This is working as expected. And finally, we have the third situation. We open the gate, we leave it less than 30 minutes open, then we close, wait a little bit, and open again for a long time. Here, the timer starts. Timer the timer will stop in less than 30 minutes. We are not going to trigger anything. Then here that the condition of the gate change against the timer starts again, and the timer takes 30 minutes, and when it finishes, it will send the push notification after the last time that it was started. So we are 100% sure that the push notification is going to be sent after 30 minutes of completely open state. So definitely using timer in this scenario is more efficient. Is you are not going to consume resources, or it's more efficient to consume resources. We avoid any kind of fast triggering because we are sure that the timer is going to start and finish in 30 minutes only if the gate remains open. So we are 100% sure about the quality of this programming. So now I would like to resume all the different methods with the pros, cons, and what are the best situation of each one of them. So let's start with delay. Delay advantage is very easy to implement. You saw that it's very easy. You can set the time, drag and drop, then you continue the programming. So it's very easy. And we can delay milliseconds. I don't know if you pay attention, but if you use timers, you can't select a timer of less than 1 second. It makes sense because it's a way more complex handle of timing, so it doesn't make any sense to use a timer for less than 1 second. From the disadvantage perspective, we have that it holds the process flow. So basically, we are stopping things, and we don't give director the possibility of use that horsepower, if you want to call that way, to use other things. Meanwhile, we went to the time finished. And once that is very important because I have been running several tests to double check this. But once we initial one delay, it can then be stopped or restarted, or even if we execute the sequence again, it won't going to respond. uh, it seems that Composer Pro inside or the director, when he starts a programming functions that has a delay and it start the delay process, it's going to ignore any other thing that trigger again the same programming. It's going to wait until the delay finished the first time that it started. So and it's going to continue with the rest of the programming. Best user scenarios to use this. It's the only option for delaying in milliseconds. This is very useful because when, for example, you want to send several commands, and you want to only add a delay to avoid any conflict between sending too much command to a device very close each other. So delay is very useful for this. And I use them if these three conditional unmet when I want to use it. If it is a short delay, less than 5 seconds, for example, is my uh, rule of the thumb. If the trigger event is infrequent and won't occur again within the delay of the time span. If it's something that it's going to it's not going to trigger again. Meanwhile, the delay is running. This is very important to avoid unwanted behavior, as I mentioned previously about this of that it when it starts and you can restart it until it's finished. And if the status of the things inside the programming are irrelevant um, during the delay. If for me it doesn't matter what happens between the delay. That if these three things are met, I can probably use delay to avoid time and make it more easy to follow programming. Let's go with the timer summary. Advantages: it's way more efficient for director. It can be managed dynamically. We can start, stop, pause, resume, etc. The timers, and we can be sure that we are not having weird behaviors if we program it correctly. And as we saw, we have timer events in the programming that could be very useful in some scenarios, like obviously if the timer expires is the most used one, is the most useful of all of them. But we have stopped, pause, etc. Disadvantage: it requires way more steps to implement it. We need to go to different parts of Composer Pro. We need to go to the timer agent to create the timer. Then we need to go to the event that we want to trigger the timer start. And then we need to go to the timer events of that timer to program against the expires or the stopped or the pause. So it's way more there are way more steps that we need to do, and well, it's a little bit more cumbersome. And obviously it's more likely to make mistakes if because of this. Best user cases definitely is the perfect tool when we need to handle timing with a precise control, and it's very important to follow the timing steps. It's awesome for the bossing behavior, for example. But basically, what we did with the gate was some kind of debounce behavior. We only wanted to trigger the push notification if we were sure that the gate was open for more than 30 minutes. Or another thing that we can do is, for example, suppose that you want to send after a lighting value change of a certain light, you want 10 seconds after that, you want to set other light to the same level. I am inventing this on the go. Um, you every time that you change the value of the light, you can program to start the timer. So you make sure that every time that this timer starts, if the timer was already started, it's going to reset. So you are 100% sure that the programming is going to be triggered after the 10 seconds of the last time you set the last value of the light. And well, in general, if I need to make a delay or I need to, well, I don't want to use the delay word in this case because maybe confused, but if I need to trigger something after more than 5 seconds, usually I don't think about this too much. I go and create a timer and program with a timer. I hope this video has been useful for you. If so, give it a like. Don't forget to subscribe to my channels. I'm going to upload more videos like this, so if you subscribe plus you click in the notification bell, you're going to receive any news about my channel. Also, leave any comment if you have any doubt or any topic you would like me to develop in future video. Hope to see you soon.